Coming up on This Week in Radio Tech, Quentin Howard, FIET. That's a title, is our guest. He's a fellow of the Institute of Engineering and Technology, and he helped introduce DAB radio not only to the UK, but to the world. We're talking to Quentin coming up here next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics with the Bionics Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey everyone, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb at the top of the tower. I'm Kirk Harnack. So glad to be here and glad that you've joined us for this show. I'm in my usual spot, the Telos Alliance studio in Nashville, Tennessee, where it's a beautiful, that's not beautiful. It's a cloudy Thursday afternoon. We've got some cold weather coming into Nashville. And then it's going to warm up just before Christmas. I don't know if I like that or not, but that's the way it's going to be. Anyway, glad that you've joined us for our 573rd episode of This Week in Radio Tech. And I couldn't be more delighted to have this fellow, and he really is a fellow. He's got a title that says fellow. He's a fellow. He's going to join us for the whole hour. It's Mr. Quentin Howard. Hello, Quentin.
Hi.
Great to see you. Welcome.
Hi. Hello from England. Hi.
Now, you haven't been knighted, have you? You're not Sir Quentin Howard.
No. There's many levels before you get knighted, and you have to have secret parties in Downing Street before you get knighted. So.
One of my colleagues posts a picture of him right in front of Downing Street. What is it? Is it 10? Is that the address?
Yeah, number
Downing
10.
Street?
Yep.
Yeah. He's right there in front of the door, and he always posts a picture like, I had another great tea this year, the annual tea. Oh my, that's my friend Martin Deister. I don't know if you ever met Martin or not. He's an intercom specialist in the broadcast world.
Oh, cool. Very good.
Well, Mr. Howard, Quentin, you have this title that I had to look up. It's FIET, and I think you're very proud of that, as well you should be. What is an FIET?
So the Institute of Engineering and Technology is kind of like the Institute for Engineers, and I'm a fellow of that. So that means that you're recognized by your peers as being, of having reached, a certain level, having made some achievements, and made an impact in engineering. So I became a fellow of that a couple of years ago. And then last Monday, the Radio Academy in the UK conferred a fellowship on me as well. So I'm a two fellow now. So I'm very, very proud of both of them and very pleased.
That Radio Academy I have heard of. I've got some friends involved with that. In fact, Dan McQuillan over at Broadcast Bionics, one of our sponsors, is involved with Radio Academy.
He is indeed. In fact, we had a Radio TechCon conference last week, and that's when they sprung the surprise on me. I was giving a presentation about boom radio, and they stopped everything and awarded me the fellowship live on air, which was interesting, lovely. It was a lovely moment. So very nice.
So we're going to be, yeah.
Go on.
We're going to be talking. You mentioned boom radio. We're going to be talking about boom radio, and you're not the programming guy you are the engineer for boom radio, right?
I'm the chief engineer, I guess. And there aren't many chief engineers about now because they're all directors of technology. But I'm really proud that I'm a chief engineer because that's the real title.
But aren't you a chief engineer without a transmitter?
Yeah, well, we have transmitters, but we don't have our own. So Boom Radio was set up in February this year on Valentine's Day, and we broadcast online to smart speakers, and we also broadcast on DAB, which is big in the UK, and we're a national radio station. So we're one of about 25 national radio stations.
We're going to be talking about that and about your engineering involvement. You've been involved in engineering in so many things, and we're not going to be able to cover them all, but a lot of significant engineering advances and improvements and programs you've started or been part of. So we're going to get to all that. Before we jump in with Quentin Howard, I want to remind you, friends, about Radio Guide magazine. You can find them online at radio-guide.com, radio-guide.com. The thing about Radio Guide magazine, you hear me talk about, is that they have room for longer articles. So if there's a how-to article, the author of the article really has room and space to tell you all about what the topic is. Here is something from Tommy Gray, the Linux connection. He's got, and look, see, a lot of words, whole lot of words. They have room in Radio Guide to go on and on about a given topic. Honey, I Shrunk the Radio Station, right here. So here's another good article. And there's room for diagrams and pictures. Here's something from Dave Dunsmore. Prepare yourself and your tools. And he's got some ideas here to talk about for getting prepared for winter, which we're just really in right now. So Radio Guide magazine, check it out at radio-guide.com. You can go online. You can read past issues or the current issue, and you can request your snail mail copy as well, if you want to get that. Thanks to Ray Top at radio-guide.com. All right. Hey, we got the next hour to talk to Quentin Howard. And Quentin, I'm not sure where we want to start. Why don't we do a little tiny bit of history? And that has to do with somebody who we both knew, and that was Steve Church. You were involved with getting some telephony to sound better back in the 1980s, I believe. What was that all about?
In the 80s, yeah. Well, the telephone system in the UK had just been liberalised. And what all the radio stations used to use to get calls on air, which was called a key and lamp unit, had loads of levers and buttons and lines. They decided they were going to stop making that, and there wasn't anything to replace it. So that's when I first came across Steve Church with his very early call-in system. And I thought, that's really neat. I wonder if I can import that and sell that in the UK. But we couldn't get it approved for use on the UK telephone system. So I scouted around and found some kit, which I then had the software rewritten to turn into a couple of decks so that you could handle phone calls on air. And we called it Telecaster. And we didn't get sued, which was amazing. So we called this thing Telecaster, and it had 16 telephone lines, and you could mix and match them, put them on air through a telephone balance unit. And pretty well every radio station in the UK had a Telecaster during the 80s. And I would go across to the NAB and meet up with Steve, and we talk about telephone systems. And then I saw him moving off into fantastic directions. And I was moving off in different directions and building radio stations and all that sort of stuff. But yeah, so Telecaster and phone-in systems was my common ground with Steve Church.
Interestingly, both you and Steve Church were early adopters and tastemakers in the world of digital. No matter how you could apply digital to audio technology or control technology. And of course, this was one of the things that Steve Church had in his first telephone hybrid was the first, as far as we know, the first broadcast use of digital signal processing, or DSP. He made a traditional telephone hybrid, but he enhanced its ability to null the send audio from coming back in the receive audio with some DSP. And your own track, Quentin, has taken, you've been making radio go digital for a long time. Talk to me about where that started. I'm going to guess something to do with CDs, yeah?
Yes, it was CDs. So I was chief engineer at GWR, which was a group of radio stations, a small group of radio stations in the southwest of England. And I remember Sony coming along to demonstrate their CD player, that big, chunky thing that some of us bought. And I put that in the studio, and my managing director thought this was fantastic. And I said, look, I think CDs are going to do really well. Let's make a big thing. Let's make a marketing thing about CDs, and let's turn the radio station completely over to CD and stop playing vinyl. So we ended up with a great slogan, which was all CD, all day. And that was the station slogan. And we just got known for being crisp, digital, good quality sound. And we made a feature of that, which is kind of unusual because you tend to think that the audience don't really care. But they knew that CD was something sexy and good, and even if they didn't have it themselves, they knew the radio station did, so that made them feel the radio station was caring about them. And so that was the first venture into all digital. And then we did CD jukeboxes. We did a CD jukebox that we controlled from 30 miles away in another studio. That was pretty hairy, all done with RS-232. But the real digital story started in Atlanta. In 1991, I think it was, the NAB, the last time the NAB wasn't in Vegas.
I was there in Atlanta. Yeah, absolutely.
Right. In the days when we were talking about FMX and technology like that.
I've got a quick callback question to the CD thing. So I was the engineer at a station that got CD players very early in the game, and I want to say it was about 1984. Could have been 85, right. But I think they traded the CD players out with the local hi-fi shop, and they got some CDs. Now, they weren't all CD. It took years to make the transition to all CD. And, it was a rock station with a deep library. So I don't know that they ever got completely off of CDs until they went to automation. When you said you went all CD, how long... Yeah. Between the time you got the CD players and the time you decided to go all CD, how long was that transition?
That was it's difficult to remember now, but probably a couple of years. But I remember when we did it. I guess it was about 86, 87 we did that, and we created the slogan. But the record companies hated us because the record reps would come round to the station and with a trunk full of records, and they'd want you to play them, but they weren't being given CD copies. And so when they came around to our station, we were saying, sorry, we don't play vinyl. Off you go. And the record companies hated us. But my head of music at the time loved the idea, and we pushed and pushed for it. And we got the record companies to give us CD masters or CDs so that we could play them. So we kind of pioneered and pushed. And it's one of those early lessons. If you believe in something and you know it's the right thing to do, you can eventually persuade the refuseniks.
Now, I would think that it would have been the same in the UK, but where I was in the mid-'80s, it seemed as though the record reps were pushing CDs because you may already own Earth, Wind, and Fire on vinyl, but now you need the digital copy of it. So they were looking at reselling the same records again digitally.
Well, I think there were two things that made CDs successful. One was that of upgrade your record collection, but you had to be quite an intensive collector to want to go that, because I don't know what they were in the States, but I think they were £15 for a CD. That was back in 1984. That's probably the equivalent of £50 now, $70. So they were expensive. But the other thing that made CDs work was the compilation albums and re-releasing old albums. And but I think when the compilation albums came along, the Now series, now that's what I call music, then people started to buy those, and that was a kind of a pivotal moment in the track of CDs. So it was a good journey for us.
I'm curious about, your source material goes from vinyl to CD. What about the rest of the air chain? Did you do anything to make sure that was as good as it could be? And for example, the rock station that I was working at, we were still using an Orban 8000A. That was our main processor. And I think I replaced some caps in it. I made it as good as it could be, but we still had an analog console. I think the weak link was probably the exciter in the Syntronics transmitter. Oh my goodness! Yeah.
Yeah.
How about you?
Well, we had a thing called the Code of Practice, which was an engineering code of practice that every radio station in the UK had to meet. And it defined the technical quality of your mixer, the crosstalk, the noise, the distortion, right the way through. And something called the worst path, which was from the input right to the transmitter, had to meet a certain parameters. So you ended up with a very high standard of quality of broadcasting. And if you were an engineer like me, you went in and you tweaked every single DA. And I used a DVM to line up everything. So I got it absolutely spot on, and I was, millivolt accurate right the way through the chain. And then our lines to the transmitter were pure copper, and they were a service provided by the telephone company, but they were 15 kilohertz, and they were plus or minus half a dB. Really, really great. And people complimented us on the quality of the service, and that was one of the reasons why we went all CD all day, because Could you hear the difference? Nah, probably not, because we were, our turntables were pretty good. They were lined up really carefully, but it just gave us, like I said, it was principally a marketing thing, but it paid off.
I think we did have some improvement. Although, on some of the early CDs, you could hear some of the problems that were hidden in the vinyl. Like there was a Billy Joel song that you could, when they faded up a guitar part, you heard some buzz. They had a ground loop in the recording studio, and you heard that. And I believe that there were probably a few CDs that were that came off of a piece of vinyl somewhere.
Oh, I'm sure. Well, do you remember they used to have 3 letters on the back, AAD or DDD? And that was supposed to tell you if this had come from an analog master or a digital master and all of that sort of stuff.
And hey, before we take our first break, there's one improvement that, and I know I work for a company that makes audio over IP gear, but time and time and time again, I have been at a radio station. Some of them have been my own stations. I've been at also network operations centers here in the U.S. And radio stations where they went from analog to audio over IP as their whole infrastructure. And I've been to places that had really good analog consoles, well taken care of. You could tell it was a good plant. And when we went to AOIP, it got better, noticeably better. And several times I've been amazed. I think there was nothing wrong with your sound before, and now it's better. Has that been your experience at all, going to a full digital infrastructure?
Yes and no. I think I've also experienced it the other way around, where you make the assumption that digital is going to be better, and it isn't. And there are some mismatches in the levels, or there are some clock problems. And I had one recently where I could hear some horrible grittiness in the audio, and it turned out to be a really bad sample rate converter somewhere in the chain, converting from 44.1 to 48, and it made it sound like somebody was rasping sandpaper over it. Now, you'd think in this day and age, sample rate converters would be great, but there's always something rogue in it. So, it's all about, in our game, I think it's all about attention to detail right the way through. Me with my digital voltmeter measuring every single point across the chain, it's the same with digital. Never assume that when you pass from one digital device to another, it's going through clean. There's always somebody who's going to muck it up on the way. So I've had experiences of both where we've put digital systems in an AOIP and you think this should be good, and it's disappointing. And you just have to unpick it slowly and work out where the problem is. When you hear that beautiful audio, it's a real revelation, and it's lovely when you get something right in broadcasting. There's nothing better. It's a really good buzz when you hear something coming out of the radio and you go, that sounds beautiful.
It is interesting. I'm considering your words, and I realize that our experiences in transitioning from analog to digital are probably quite different. I worked at smaller stations, and I totally missed the whole AES3 or the AES-EBU era. I almost never implemented that anywhere. And so sample rate converters have rarely been part of anything I've ever dealt with until I got to AOIP, where you sample rate it once coming in and it stays the same. It doesn't change until it's delivered to the transmitter typically. And so I missed that whole era, but I knew engineers who would say, oh, this CD player or this is causing me a problem. Too many sample rate conversions, and the early sample rate converters operated only at about the 12 to 14 bit level, even though it's supposedly 16-bit audio. And today's SRCs, 24-bit audio in and out, typically they're operating at 20 or 21 bit depth for the SRC. And so this gets it down below the noise floor that we're worried about.
And it's the aliasing. It's the aliasing that you can hear often when it's only 14 or 16 bits that make, it's part of the reason it sounds gritty. But also some of it's just, really bad design. They're using a horrible chip or whatever it might be. And I've come across with the AES-EBU side, people plugging AES-EBU together and then wondering why it's 6 dB higher on this side than it was on this. Oh, hang on, it's digital. Just do that. There's always a setting somewhere. Do you want to add 6 dB? Do you want to take it away? And it's just about checking all the way through.
Interesting, because as an engineer, I totally missed that the things you're talking about. Never experienced, because I just missed the whole AES-EBU era. How about that?
I think digital is harder because you very often you can't hear it all the way through. You can't hear every point. And with analog, you could take your headphones or your test telephone, and you could stick it into the punch blocks or the whatever, or the jack field. I've got a jack field in my studio here, which never gets used now. But my goodness, they were useful.
And you can make value judgments, and I'm sure you're probably like me. There were some pieces of audio that your brain knows every tiny quiver and waver of what it should sound like, and if you listen to that, if you can play that through the chain, if it's right or not.
I did a lot of listening tests on digital systems. I helped aptX develop some of their Bluetooth technology. And I was a big fan of their codec. But before that, we put together listening tests for digital radio to look at bit rates and see if we could get better quality MPEG-2. And prior to that, we put listening tests together for in the UK. We weren't. This is amazing to your US viewers. We weren't allowed to use processors on the outstation output until 1985. They were banned by the government agency. But to get them approved, we put together some listening tests, and we picked particular pieces of music which are well known for testing, particular parameters. And once you train your ear, you hear these things every time. You hear this little violin. There's my favorite piece of music for testing systems is Mozart's Piano Concerto No. 21, and it has violins and piano, which are the two hardest things for systems to reproduce. And I did a test once where we were trying to show how bad it was when you multiple coded audio. And I produced a demonstration tape of a piece of audio encoded and decoded, transcoded 17 times through different systems. Yeah. And you're lucky you got anything out the other end at all. But what it did show was which were the better systems, which were the ones that destroyed audio when it went through 2 or 3 passes. And that piece of music, that Mozart Piano Concerto No. 21, is called Elvira Madigan, because that's the name of a film it was used in, is not only a beautiful piece of music, but it absolutely destroys your codecs. So that's my tip.
We are talking to Quentin Howard, FIET fellow of the, is that Institute of what?
Engineering and Technology.
There you go. And we are talking to Quentin. He's going to, when we come back from our first break here, Quentin's going to talk to us about DAB and how he was part of getting DAB going in the UK. And I thought that they were totally stuck with MPEG Layer 2 on DAB, but Quentin's got some good news for us that they've actually been moving ahead with a better system there. And we're going to be back to talk to him in just a minute. Our show, This Week in Radio Tech, is brought to you in part by our friends also in the UK at Broadcast Bionics and their Camera One system. We'll be right back.
Camera One from Broadcast Bionics. Designed to bring video to your audio content. Visualizing radio and podcasts for social media. Camera One can automatically create, capture and brand professionally switched video for live streaming or upload, making your production shareable. Control and configure using a web browser on any device. Camera One is available as a 4-camera or 8-camera system using the Blackmagic A10 Mini range, including the A10 Mini Extreme. You can use cameras to suit your studio and your budget. You'll need 1 camera for a studio wide shot and usually 1 camera per microphone. A standard multi-channel sound card or IP driver monitors audio from each studio microphone, and we work natively with Axia systems. Ideally, this will be a post-fader feed from each mic, although you can use pre-fade audio or a mic split if that's all you have available. These audio levels are used to intelligently switch the video feed when each contributor is talking. You can also group microphones together into one shot and use the audio from a mixer's aux bus. You can use Camera One's auto switch feature, or disable it and switch using the on-screen buttons or the buttons on the A10. Recordings can automatically start when you tell the system you're on the air. This on-air indication can be linked to your studio's red lights via IP or an Avantec Adam GPIO interface. You can quickly browse all the videos that have been automatically created during your broadcast, download them and post. Camera One is a user installable system. You'll need a good spec Windows 10 PC, i7 with plenty of storage and 16 gig of RAM. It's better if this machine isn't used for anything else. Remember, you can control the software in a web browser on another device on your network. Camera One, a thrifty way of creating scroll-stopping video from your show or podcast from Broadcast Bionics.
And whether it's Camera One or any of the other incredible pieces of software and hardware that is offered by Broadcast Bionics, check it out. They'll make your station look better, sound better, and have a really good social media presence. A great way to promote yourself. And, for example, contest winners, to give more information about artists being played and their songs and when things are coming up. So check it out at bionic.radio. That's their website, bionic.radio, and Camera One. Thanks a lot to Broadcast Bionics for sponsoring This Week in Radio Tech. And a shout out to Dan McQuillan and Duncan. Hey, Duncan Smith, everybody there. We're talking with Howard Quentin, and he's been involved with radio in the UK forever, just about. Howard, we were going to talk about DAB, but I realized I skipped over something important. You talked a minute ago. You said that there was no processing on radio in the UK. Was that just on FM, or was that AM as well that didn't have processing?
In many cases, AM didn't have it either. It was viewed, there was a very patrician view of broadcasting in the UK, which derived, I think, from the BBC as well, that it should be a pure system, that there should be no adulteration. And I think the concept that a processor gave a station a sound and identity and was part of the production process just wasn't accepted by the grey-haired mandarins who ran the whole thing. But a group of us engineers of radio stations, chief engineers, and some people inside the authority who ran the broadcasting network, we pushed for processors because FM wasn't really taking off. AM was the predominant means by which people listened to radio, and we will simulcast, so it was the same thing on AM as FM. So there wasn't a great deal of choice either. And long story short, we tested some processors and we approved the Optimods and we approved the Inovonics 2050. And they became the two dominant processors in use in the UK for about 10 years. And then we've now got Omnias and everything, and it's all deregulated. And everything moves and the needle doesn't stop. So it's
well, there could be a right way and a wrong way to use a processor. Now, wait, hey, before we took our commercial break, you had a VU meter on your chest. What's going on?
Yeah, I've changed. Here? Well, this is for the Europeans and the Brits. This is the PPM, and the PPM was invented because a presenter at the BBC got drunk on air. This was in
What's that story?
In 1937, there was a presenter called Tommy Woodruff, who was a Navy lieutenant, and he was given the job of commentating on what's called the Spithead Review, which was a sort of a sail past of the Navy fleet. And they handed over to him, and he was standing on the edge of the docks watching these ships go past. And it's a fantastic broadcast, but he kind of gets drunk as the whole thing goes on. And in the way that broadcasting worked in the BBC then, they couldn't take control back because the engineers did not have editorial control. And they'd plugged the thing in and they weren't allowed to take it off. And the producers who were in charge of the output couldn't take it off themselves. They had to get the engineers to do it. So there was kind of like a clash. So they needed something so that presentation announcers could control the input and the output themselves on some kind of fader system. And for that, you needed a meter. So they invented the PPM. And that's how the PPM came about, because of a drunk presenter.
Having never used a PPM myself, you've used equipment with both VU meters, with the VU ballistics, right, and PPM, and I'm sure modern digital meters. What's it like running a console with a PPM meter?
It's what you're used to. I think everybody in the UK, I think, would say that they prefer a PPM because it behaves more like your brain does. It's a logarithmic scale. So it reacts in a way which is more like your hearing expects it to be. And it's quite controllable. With a VU meter, it's kind of all crushed up at one end. And people here find it harder to control. There's also a lot of VUs that aren't VU meters. They don't have VU ballistics.
Absolutely.
And when you get a proper, what I call an American VU meter, then you begin to learn how to use it. So it's horses for courses, really. I think the recording industry, like VU meters, the broadcast industry in the UK and across Europe, have variations of PPM meters. And your good selves and the Canadians and everybody else uses VU. So there you go.
You know, on these audio consoles made by my employer, Axia, we've had consoles that had a variety. You could choose from like 6 different ballistics, and one of them was, I want to say, Nordic PPM, perhaps. Yep. And yep. I like the look of that one the best. I thought that was just the prettiest.
Well, the prettiest meter out there is the Duros, isn't it? Everybody likes the Duros meter.
Yeah, well, like I've got, right here,
which is that one there,
me.
Yeah. But I was taught to use a PPM, and it's a really simple thing when you're teaching a self-op jock how to control the levels. It's music at 4, speech at 5, and phone calls at 6. That's it.
Oh, okay.
And right. You make it simple, and then you get good levels out of it. And if you feed good levels into your processor, the output will sound fantastic.
So now you mentioned this Inovonics processor, and you put one on a classic FM station output, and this was some people thought this was just horrible, and some people thought it was. And by the way, I wanted to ask you. Yes, I understand the purists wanted wanted no processing, but wasn't there any consideration for the fact that the range of a speaker in terms of loudness to loud to softest, and the range of the human hearing are much greater than the range available in an FM transmission system, which may only have 50, 60 dB of loud to noise. Isn't processing useful just to overcome that?
Sure. Well, but it's actually for overcoming background noise in the environment you're listening in. If you're listening to the radio in your kitchen, and there's washing machines going, or if you're in your car, you've got a background noise of 50, 55, 60 dB, and you need to reduce the dynamic range. It's as simple as that. But because of the tradition of British broadcasting, and particularly when it came to classical music, there was this feeling that it's too precious to play with. You have to, just let it go exactly. And so the main classical station in the UK, Radio 3, run by the BBC, had a dynamic range probably of 40 dBs typically. And you spend all your time, adjusting the volume control. So when we built Classic FM, which was, it was the first national FM station in the UK, run a commercial station. The BBC had the monopoly on national stations. They had 4. So this was the first national station commercial. And it was the first time anybody had taken on Radio 3 head-to-head with a classical music station. But my approach to classical music was, look, this is a rock station from Mozart's time. If Mozart had been alive, he'd buy a processor. So, and I was going to make sure our audience could hear the station. So I put the Inovonics 250 on the output of my my studio at Classic FM, fed all the transmitters around the country. I had 40 FM transmitters with this processor, and it sounded beautiful. And I didn't overprocess it, but the Inovonics was very kind to classical music. The results, the proof was in the pudding. Our first survey results, 3 months after we went on air, we had 4.5 million listeners. There you go. Now, if we'd not processed it, I think we would have had half of that. Now, and I did get letters.
Sorry, go ahead.
I got letters from the Hi-Fi Brigade, as you might expect, saying telling me how I ought to run my station. And my view at the time was, look, if you want to sit with your ears 6 foot apart in an oxygen-free room listening to music, you do that, but go and buy the CD. My radio station is broadcasting, not narrowcasting. And the complaint stopped because the public voted with their ears and they tuned into Classic FM. And 30 years later, that station is still getting 6 million listeners. It does fantastically. And it plays a format of music that many people would say is minority. Well, it ain't minority. People love it.
I got to believe that processing that you put in place simply acted to lift the super quiet parts up so you could hear them without cranking the knob up. You still knew that you had left the radio on. And then now, how would you come about overcoming, like if there's supposed to be a really loud timpani drum and some blasts of the horns, how would you keep those from getting squashed and the same volume as everything else?
So the answer is they will get squashed a bit, but it's just about how you set the processor up, how you set the AGC, the recovery time on the AGC, how you set your multiband processing. And one of the things I found with classic FM was that final clipping was actually really important. And so, but I didn't do the final clipping on the output of the Inovonics, which isn't the loudest processor in the world. We all know that. What I did was I put the final clipper at the transmitters, and I used an intelligent final clipper which could invert peaks so that you could get a few more dBs out of the whole thing. So I had about 2 or 3 dB of limiting going on, and we were pushing nearly maximum deviation, and it sounded beautiful. It just sounded nice. Now I've done the same trick with Boom Radio, which we'll talk about later on, I guess. But that isn't processed very hard. But I do have some final limiting and clipping going on, which makes it just sound a bit more punchy.
Let's talk about Boom Radio and DAB coming up in just a few minutes. It's This Week in Radio Tech. Quentin Howard is our guest today, and he's bringing us not only history, but he's going to bring us right up to date on what's happening in UK broadcasting in terms of DAB and DAB Plus and Boom Radio, and why that's fun for people my age and Quentin's age. Hey, our show's brought to you in part by our friends at Broadcasters General Store. You can get anything you want at Broadcasters General Store, not to steal a song lyric. And this week, it's the Henry Engineering Super Light. Now, for years, engineers like you and me used the Henry Engineering Super Relay to connect up all kinds of things. If we had a cheap console that didn't mute the speakers for us, well, we would use a button on that console to mute the speakers, to disconnect the speakers from the amp when the mic was turned on. We might also use it to turn on, of course, a tally light over the door to keep people from coming in, maybe. Some stations actually used it to lock the door. Not necessarily a good idea. But we also used it to hooked it up to the capstan motor on a cassette deck. Remember that? You'd automatically telescope your air checks. Well, the Henry Super Light is the replacement for the Super Relay. Now, they still have the Super Relay if that's what you need. But the Super Light is meant to work with the new LED lighting systems that you'll find in so many broadcast studios today, whether it's the LEDs that are part of a microphone boom assembly, or whether it's the LEDs that now are on the next to the door or over the door outside. The Henry Super Light can take care of that for you. It's got a lot of cool features, and you know what I like? Hank Landsberg, who runs Henry Engineering, he gives you schematic for his products. So if you need to troubleshoot something or see exactly, well, how does that actually work? Right there's a schematic. Here's the manual, one sheet of paper. And I know it's a simple device, but you need to know how it works. You need to know how, hey, I can make that tally light flash on and off, or I can make it steady. It also has normally closed and normally open connections for running things like, well, if you're still running a capstan motor on a cassette deck, you and I need to talk, but you can do all kinds of things. You could disconnect your speakers, for example. If you still have a telephone that maybe needs to get muted when your mic is open, well, you could mute that. You could run its ringer or speaker right through here. So there's another feature here. You see these two RJ45 connections? Well, that's not Ethernet. In fact, neither is it Studio Hub standard. The Henry Superlight LED tally light controller, they're addressable. So if you need to put several of them in a row, look at that right there on the screen. If you're looking in the lower right, you can daisy chain several of them together. Let's say you've got for example, a GPIO node from Axia. You can wire out of a GPIO node and then daisy chain into the Superlight number 1, number 2, number 3, and number 4, and you can set a little address inside each one to make them fire when the appropriate studio fires. So you can simplify your wiring. That's really the grand point here. Simplify your wiring scheme with the Henry Superlight. And like everything Hank Landsberg makes, it is durable. It'll last. It'll last longer than your studio, I believe. And check out the other things that Hank has at henryeng.com. henryeng.com is the website for the Henry Superlight and all the other things that Hank Landsberg makes. And you know where you can get them? You get them from my pals at Broadcasters General Store. If you think there's something for broadcasting that they don't carry, you're probably wrong. bgs.cc has a whole list of what they carry there. But more importantly, you should give them a call. They're really set up to talk to you on the phone because they're nice people. And you give them a call at 352-622-7700. That's 352-622-7700. Talk to John or Jessica or Buck or Hugh or anybody there at Broadcasters General Store. Tell them I sent you. That'd be really nice. Thanks a lot to BGS for sponsoring This Week in Radio Tech. Our guest is Quentin Howard, and we're talking about, I think, Quentin, we're going to have to skip the ISDN bit here and move on to the DAB bit. I remember these days in the mid or early 1990s when there was a push in the USA to maybe go DAB here. And I had a grand money-making scheme. I was going to own the multiplex sites that other broadcasters would come to. And then all that fell apart, and broadcasters in the U.S. didn't want to, well, a Class C FM, 100,000 watts, didn't want to be on the same footing as a community station with 3,000 watts. So that kind of got the kibosh, and HD radio came to be. But in UK, you've got DAB. Tell me about what your involvement was beginning with DAB.
Yeah, so the first time I saw DAB was at Atlanta at the NAB. It was being shown by the European Broadcasting Union. Very early stage technology. It had only been under development for about 3 years, but they were demonstrating a system where you could have 12 radio stations sharing the same block of frequency using a modulation system called OFDM, which basically time sliced and frequency sliced all the radio stations together and then broadcast it as a block. We're used to that multiplex idea now, but back in 1991, it was kind of like, it was like the Apollo program. It was just amazing. And there was a magic moment for me. I saw it and the light went on in my head and I said, okay, this is what radio needs because it will deliver more choice, which is what the listener wants. It'll be able to deliver text. It has the ability to deliver pictures. And I just kind of knew that those things were going to be important. This was, long before the internet. So the following year, NAB went to Vegas and they set up a demonstration of the DAB system in Vegas, and people could drive around in a bus and have a listen to it. And there followed a move by the NAB to adopt DAB, the European DAB system in the States. I remember Eddie Fritz standing up at the NAB and saying, this is fantastic technology. We in America must adopt it too. And that went down like a lead balloon. We skip forward to 1995. There was a shootout of 3 different systems, digital radio systems. There was a satellite system, which was a forerunner of Sirius XM. There was the forerunner of HD radio, which I think then was called USA Radio or USA Digital Radio. And then there was DAB. And they all set up simultaneous tests in San Francisco, which was picked because it's difficult to cover San Francisco, as we know. And the results showed that the DAB system was the better system, but it used multiple transmitters because DAB works having synchronous transmitters. Mm-hmm. But by then, I think the momentum had grown in the States for a homegrown system. It was all to do with intellectual property, as these things often are. But Europe was going its own way. So I got really involved at that point and I became an evangelist for DAB in the UK. And then I persuaded my company, the GWR Group, which by now was a group of about 30 radio stations, that we should pioneer DAB for the commercial sector. So we set up the very first commercial radio DAB test in the world in Birmingham at a trade exhibition. The BBC started their tests a year before in 1995. And then in 1998, a license was offered which would allow for a national DAB multiplex in the UK, which I bid for. I put the bid together, I won it, and we called it Digital One. And that became the national broadcast platform for commercial radio, for digital radio. And immediately, the choice of radio, FM, AM, and digital radio overnight doubled thanks to Digital One. So we were giving the listener more choice. The only snag with that is there were no DAB radios. The cheapest radio was £600, so $1,000, and that's not a price that the average consumer is going to go and buy. So I was spending a bit of time in Japan meeting the manufacturers, Sony, Pioneer, the car manufacturers, and the domestic audio manufacturers, and they all had plans for DAB, but they kind of weren't really getting on with it. And the problem was that the chipset for DAB was it's about this size, a PCB about 10 inches by 10 inches, stuffed full of components. And just the cost of manufacturing that was about $300 out of the factory. So you couldn't make a low-cost, low-powered digital radio out of that. But the guys at Panasonic showed me their roadmap of chipsets over the following 10 years, starting with this massive board, getting down to a single chip the size of your fingernail. And I just casually said to them, what's stopping you building that chip there, the little tiny one? He said, nothing, we could build that today. But that's not how we do chip development. We do it in stages, and each stage has to pay back the R&D of the previous stage. So I said to him, if I was to invest in and pay for you to build that chip, how much would it cost me to build the small chip? And he said, about $3 million. And I said, in the scheme of things, that's not expensive. So I put a proposal to Panasonic, Matsushita Panasonic in Osaka, and it went all the way to the top and came back down again with a no. They weren't going to do a joint venture with me, with my company, Digital One, because they'd never done a joint venture before and they didn't know how to. But as often happens in these things, I bumped into another guy, a company called Imagination Technologies, and they made the video chips that go in Sega game consoles. They're based in the UK, just outside London. And the guy who was developing this equipment for Sega game consoles happened to be a DAB nut. He liked DAB, and he said, I'm going to make a DAB radio. And so they did. And to cut that long story short, I did a joint venture with Imagination Technologies because they were what's called a fabless silicon company. They make silicon, but the silicon's done somewhere else. They design silicon,
right?
And so we made the chip. And actually, this is it. This is the chip we made.
Oh my goodness!
Yep, that's the first low-cost DAB chip, and it's called the Chorus chip. And we designed it together with Imagination Technologies, and it was the features inside that chip defined how digital radio works now. It defined how you tune into a station, how you see a little strength meter on the dial, how you order the stations, what happens if you move your radio to an area where you're not picking up those stations, how do you get rid of that list of dead stations, and all those kind of really important things to make the user experience really good. So that chip we did, and part of the deal that we did with this chip with Imagination Technologies is they had to make a radio which would sell for £99 without any subsidy in the shops. And that radio was called the Evoke. I've got one over there. I could go and get it and show you, but
I remember that
it's
name.
Famous. Yeah. Actually, I will go and get it because it's the most famous radio. Hang on, I'll just pop over.
Yeah, I remember that name, the Evoke, and I'm curious to find out if that chip.
There we go. This was the Evoke. Hang on, let me just get me a piece back in again. I'm falling to bits here. So that's the Evoke.
Yes.
Okay, so that's the radio we made for £99, and they flew off the shelves. People could not get enough of them. This radio is now, I believe, the biggest selling radio ever in UK history. This model. Do you see it's made of wood?
I'm curious, that chipset, did it have any RF tuning on it? So was it RF and audio and display too?
No, no, there was a separate RF chip. But a later iteration of that chip had the RF on one side and the digital processing and the audio decoding on the other side. So it was like a double-sided chip. And the evolution of that chip now is in a device like this. This is a typical kind of portable radio. that you can buy in the UK, and these retail for less than £20.
Really nice.
So that's where it's got. And if you think about it, it's actually cheaper than an analog radio now.
I'm sure you're going to tell the story, but my impression has been that there was a problem with this, though, that being the first, you kind of got locked into MPEG layer 2 as the codec, and bit rates, MP2 was great, 20 plus years ago or 30 years ago, but it doesn't scale down in bit rates so much. So talk to me about how that was a problem, and if you guys have overcome that problem.
So the two problems were, one, you're right, we were using MPEG, what known as MPEG 2, but that allowed us to get about 10 or 12 radio stations in a multiplex in a single block of frequency for DAB. Mm-hmm. And that was only if you were kind of squeezing the bit rates, and some of it was a bit grumbly. There was also, by then the world was moving on to AAC, and DAB was stuck with MPEG 2. And it was getting a pasting in the press. The press were really having a go at DAB. I don't know why, but the journalists, including BBC journalists, kept on slamming it and saying, this is old-fashioned, it's rubbish. No. It wasn't, but that's what they were saying, and people believed it. So by then, the World DAB Forum, which is kind of like the industry body for DAB around the world, I'd just become the president in 2005 of that organization. And the very first thing I did was I said, look, guys, we've got to upgrade DAB, because if we don't upgrade it and have a better codec and more efficient audio encoding inside that same multiplex, and it has to be backward compatible in some way, then the risk is that DAB will fail, because it wasn't a dead cert by that time. We had the Evoke radio, we had the chip, but we didn't really have other countries adopting it at the speed at which the UK was. So the very first thing I did as president of World DAB was I said, I want to get a working party together to produce a DAB Plus standard, which is going to use whatever codec is the right codec to use. Let's do a call for technologies. And we put a committee together, and I said to them, how long will it take you to get this from this point here, call for technologies, through to published ETSI standard? And the guy who was running it said, about 18 months if we're lucky. And I said, I'll give you 9 months. And we did it in 9 months. We did the entire thing in 9 months, from call for technologies, decided on the codec, worked out how the Reed-Solomon coding would work, additional features, super blocks, all that kind of stuff that you need with this kind of technology. And we published the standard in February 2007. And that became DAB+. Okay. Which is now in every radio now that's sold in the UK is DAB+ compatible.
Does that mean that there are the older radios like that Evoke, is that not useful for some channels then?
No, it is, because there are still lots of radio stations that transmit in DAB, the old-fashioned DAB. There are still lots of them. And the difficulty when you change a standard is, how do you migrate everybody? Because you have an installed base of receivers that are not compatible. And so people were reluctant to go for DAB+. And really, to do DAB+, the thought was you needed a sort of a dual strategy where you'd launch a station on DAB+ as well as the DAB version. That takes more spectrum, that takes more bit rate. So that's not really workable. But one or two brave stations early on in the UK just said, we're going to go DAB+. And they started off with DAB+, and they found that actually it wasn't as big a problem as they thought. Other countries like Switzerland went DAB+ from day one. They bypassed the old technology, and they just went DAB+. So around the world, I think there's 37 countries now running DAB in some form or another, and nearly all of them are DAB+ now. In fact, the UK, because we were the first, we've got the biggest problem, and the biggest problem is switching the BBC over to DAB+, because they're frightened, understandably, that their listeners will react badly, that their lovely radio that they bought for £99 doesn't work anymore.
Hey, let me backtrack and ask a couple of follow-up questions here. A lot of folks who haven't been, I barely know the difference between DAB and DAB+. So I know that DAB+ allows you to use more efficient codecs. It's not locked into MPEG layer 2, MP2. What are some other differences in the technologies in DAB and DAB+? So what are countries that adopt DAB+, what are they getting for their broadcasters?
It's principally greater efficiency. So there's no change in the RF side of things. There's no change in the multiplex. There's no change in the OFDM modulation technique. The only change is in how you present the bits to that. In an MPEG-2 multiplex, as I said, you get about 10 or 12 radio stations. It's a total of 1,152 kilobits. So 1.1 megabits is the bandwidth of a DAB multiplex, okay? But with DAB+, it's an AAC family of codecs, so you can go from 24 kilobits if you want to, which Boom Radio does, right the way through to higher bit rates, 96, or if you really wanted 128, but actually you're up in the stratosphere then. Most stations on DAB+ in Europe are on typically 48 kilobits. And in the UK, we tend to be 32 or 48. So those are the sort of typical bit rates. Every country regulates it slightly differently, but typically you'll get 20 to 25 radio stations in that same space, so it takes the same amount of spectrum. In that same 1152 kilobits, you can get 25 radio stations. And that changes two things. One is it gives the listener a fantastic amount of choice. The second thing is it reduces the cost of transmission for each of those radio stations. Because it's a shared transmission system, each radio station pays a percentage of the total transmission cost to be broadcast on that multiplex. And if you've got 25 stations sharing the cost of your transmission network, your costs are going to be a lot less than if there's only 10 stations sharing it. Yeah. It's simple economics.
So, I have so many questions. And I'm sorry, go ahead. Go ahead and finish your thought.
No, I was going to say, so here's an interesting sort of difference in the psychology maybe between the way that the UK looks at radio stations and the way that, say, the US looks at radio stations. In the UK, we were happy to have more choice, but eventually the groups will buy up all the choice there is. So we've got two large groups in the UK that probably dominate 70% of the commercial radio market, maybe a bit more. But what those groups did was they said, okay, so let me take a particular brand. There's the Heart brand, owned by the Global Radio Group. So they have Heart Radio, but they've launched Heart 70s, Heart 80s, Heart 90s, Heart Noughties, Heart Christmas. You can have pop-up stations that are only there for a month. So you broaden the choice, and listeners have changed their habits over the years. And this is what I spotted in 1991, that listeners were not going to be loyal to one radio station anymore. With lots more choice, they were going to be more promiscuous in their listening. And the way to keep your share of audience is to have more stations and give the listener more choice, but still own the listener in the entire journey. And that's how it's played out in the UK. But the other thing it's allowed is challenger stations to come along and play on an equal footing with the big boys. And that's what Boom Radio's done.
I wouldn't expect the big radio stations, the big boys, would like that, though. So here comes Boom Radio taking away some of their audience that they're not serving. We're going to talk about Boom Radio in just a bit of remaining time we have left. But I got to ask you an RF question, though. I recall that one of the problems with DAB coming into the U.S., I thought that there was, I'm not sure about this, it was L-band spectrum, and in the U.S. that was taken up by our military, as I recall. And they weren't going to give that up, so the DAB was going to have to go in a place that it wasn't going to penetrate as well. Is DAB, does it tend to be the same spectrum in all the countries that adopt it, or is it in different little areas?
It is now, yeah. But it tends to be band 3. So most DAB is in band 3. So in the UK, the DAB is between 174 megahertz and 230 megahertz, which in a lot of other countries is where terrestrial television sits. But we haven't had terrestrial television in that band since about 1984. So that band was sitting there doing nothing. And it was an easy way for the UK to get into it. It's more difficult in some countries in Europe. France, for example, We could talk a lot about that, but let's not. But France has band 3 television in the place where DAB is going. And what they're doing now is they're shuffling DAB into the band 3 space in between the television. And eventually that terrestrial television will go to UHF and that band will become free. So it was band 3, but Canada adopted DAB for a few years and they did it on L band.
Yes. Okay.
Which is 1.5 gigahertz.
Yeah.
And it was okay. It worked as predicted. What a surprise! The difficulty were there weren't any chips that would decode it. So they were early in the game, and what killed it for them was two things. One was Sirius coming along and offering a transnational radio service, and the second thing was the high cost of L-band transmission and the lack of receivers. So three things.
I was afraid of this. We're going to run out of time. I got to do a quick break to talk about a couple sponsors. We'll spend the rest of the show, which is only going to be about 8 or 9 minutes, on Boom Radio. I know that's your love, and I want to hear about that and how that came to be. This Week in Radio Tech, I'm Kirk Harnack. Quentin Howard is our guest. Quentin, I'll put a link to his LinkedIn. You can read all about some of the things that he's done and the technologies that he's been part of introducing and adopting and promoting. Hey, our show's brought to you in part by our friends at Angry Audio. AngryAudio.com is the website. And they make this really cool thing here. How many times have you needed, oh gosh, this would be bad. Look at this. If you had the 3.5 millimeter going into your headphone amp and your headphones have a 1/4 inch connector on them and you get up and walk away, what's going to happen to this poor little 3.5 millimeter thing? Pop. With the disconnector, it just comes right apart. It's like the MagSafe connector on Apple laptops. It just comes right apart and it goes back together. And guess what? It goes together correctly. You won't reverse the left and the right because it doesn't go together wrong. It goes together the right way. Why didn't somebody invent this sooner? Angry Audio makes the headphone disconnector. Let me put the right one with the right one here. There we go. You can, here's 3.5 millimeter on each end, so you've got the little version. And then here's the 1/4 inch version on each end. There you go. So many headphone amps today have both sizes on them. So whatever your headphones are, but the headphone disconnector is just such a great, awesome little product. And at Angry Audio, they bought lock, stock and barrel. They bought Studio Hub. And so that means you can still get all these convenient wiring accessories, the Studio Hub Plus wiring scheme from Angry Audio. Call your favorite dealer. And if they offer you something else, say, no, I want Studio Hub, because they have spent a lot of time and money getting these connectors, getting these stranded audio cables to correctly work with RJ45 plugs. That's a trick right there. And Studio Hub solved that problem years ago. So you're not going to have problems with these. I like this kind right here, where you just choose a patch cable to go to your Axia X Node or your Wheatstone Blade or your other Studio Hub gear. And if you're doing AES EBU digital, well, then they have just the single ones for this, like this, By the way, if you're doing AES digital and you've only got one of these stereo analog things, guess what? You can just use the left channel, that's the AES, and tie this one back. Or if you're really sure about things, you can just cut it off right there. Yeah, I know that seems wasteful, but anyway, that's what you can do right there. Studio Hub, they got all of it at angryaudio.com. So many accessories. They got here's the IHF to Pro. Oh, there we go. There's the website, angryaudio.com. Check it out. There's the IHF to Pro. Look, a little bitty block right there. And that does goes from your RCA cables to your balanced +4 audio. And if you need to go from analog to digital, well, right there's an analog to digital converter. You can get your unbalanced left and right going in, or your balanced stereo in, and you can come out as digital, AES EBU digital right there. Yeah. And so cool. Powered by 15 volts. Check it out, angryaudio.com. And also our show's brought to you by our friends at Max Connect Wireless. Gary Morrill stopped by, and he has a little testimonial about Max Connect. Let's hear from Gary.
I'm Gary Morrill, Midwest Regional Director of Engineering for Alpha Media. When I first spoke with Josh Bone about Max Connect, he told me they'd work great for remote transmitter sites where connectivity was a challenge. And he's absolutely right. We even have sites where we're using this as a backup to our STL using Max Connect's dual carrier option, and it works perfectly. We also have times where we need to be able to get out to a venue where it's kind of challenging because everybody and his brother is trying to stream video at the same time, like at a big sporting event. And you know what? Our data gets through every time because it's prioritized packet data. It works for us. It'll work for you. Max Connect. Check it out.
Hey, and I got one too. Thanks, Gary. He had the Cradlepoint one. I've got the PepWave one, but it really doesn't matter which 4G LTE modem that it is because the modem doesn't matter. It's the SIM card that goes inside. It's the Max Connect wireless SIM card that connects you to your favorite carrier, Verizon, AT&T, T-Mobile, Sprint, and it tells the carrier, hey, I'm part of the Max Connect network. I want prioritized data, and that's what you get. Your data packets go before everybody else in the stadium, except first responders. They get priority, but that's not going to cause you a problem. So many stations are using these for remote control to their transmitter sites where so often you can't get internet except by 4G LTE. Check it out, Max Connect Wireless at maxconnect.com. Yeah, it's spelled funny. There's a link in our show notes, so you can click on it from there if you go to thisweekinradiotech.com and look for it. Thanks a lot, Josh Bone, for sponsoring This Week in Radio Tech. Okay, we've just a little bit of time left. I know that Quentin's excited about a format that I think is really cool. It's Boom. Quentin, what's it all about? What's Boom?
Boom is a radio station for baby boomers. Baby boomers are the people who were born between 1946 and 1964. Me too. And many radio stations are just ignoring that audience now because the advertisers don't think there's money there, but there's tons of money in people who are, baby boomers are more money than anybody else, apparently. Not me. So we saw a gap in the market, and a couple of guys who've been in the radio business for a long time, Phil Riley, who ran the Heart Network and Chrysalis Network, and is like a god in radio, and an inspired programmer called David Lloyd, whose books you should read on how to be a radio presenter. The two of them put this idea together, and they rang me up and they said, look, we're in the middle of a pandemic. We want to launch a radio station. We don't know whether we can do it with everybody working from home. What do you think? And I love a challenge. So I said, yes, of course we can. And then I thought, how the heck are we going to do this? But we put a station together where all the presenters work from home. They don't have nice studios like I've got here. They just work in their attic and their office or their cellar, wherever they happen to be. And they voice track the station by and large. We use Zeta for that. Mm-hmm. Do we need an office? No, we don't have an office. So in the UK, RCS, they host a whole load of radio stations at their head office in the south of England. So we said to them, can we rent the kit and the software? Can we have RAS, radio as a service, like SaaS? So they said, yeah, sure, come on board. So that took away all of the hassle of having to look after hardware and racks rooms and IT guys and all that kind of stuff. They do all that. All I had to do was to work out how to get our signal from the presenters at home into the RCS system, and then how to get the signal from the RCS system out to the internet and out to our DAB transmitters. So the first thing I did was to look at microphones, and I had a lovely opportunity to buy about a dozen different brands of microphones, things like the Rodecaster, the USB mic. So I bought one of those, and I bought the Blue Yeti, which is the other famous sort of podcasting mic. And I tried a whole load of mics, you can see at the back here, with XLR to USB interfaces, because we were going to plug it into a computer and then it was going to go into the RCS system using Zeta to go. The interesting thing there was trying to make sure that I could find a mic which was pretty good on the acoustics, regardless of the environment. So the way I tested it was empirically. I wrote a script. I recorded the script into every make of microphone I had, all 12 of them, in 5 different rooms in my house, in the kitchen, in the conservatory, in the lounge, in a bedroom, in the office. So it replicated the kind of acoustics you might get in any of my presenters' homes, wherever they live. And from that, I was able to pick the best of the best. And it really came, interestingly, down to 2 microphones. One was this one, the Rode NT USB, which is beautiful because it's got headphone controls, mic controls, mix controls, so you can mix the cue music coming back, all the usual stuff. Some don't do that, surprisingly.
Right.
And it's really controllable. And the other one was the Blue Yeti, which was similar, but perhaps not quite as controllable, but it had a nice tight cardioid shape on it. So those are my two go-to mics. We then set up the streaming. We did streaming through a company called Sharpstream, who do a lot of streams for radio stations in the UK. And they have a nice backup system so that if you lose your connection from the playout system into their data center, then it automatically falls back to pre-recorded audio so that your listeners never go silent.
Right. Right.
And then I fed our DAB transmitters in a variety of ways and make sure they got backed up. So we've ended up with a system which is duplicated playout systems. There are two Zeta playout machines, Auto 1 and Auto 2, running the schedule. The whole thing is VT'd. But where VT gets a bad rap from people, it's not real radio, it's not live, our genius programmer, David, and his genius partner who does all the music, Paul, they said to the presenters, look, you treat voice tracking like it's live. If you make a mistake, just let it go. You wouldn't have a chance to redo it if it was live. So you've got to get into that same mentality of you're doing it as if it's live. Now, that has worked brilliantly. The station sounds relaxed. It sounds terrific. We don't play 5 in a row and a link. We do a link almost every other record.
Oh. Okay.
And so there's quite a lot of speech content in there, but the presenters are knowledgeable. The presenters have all been around donkey's years. The average age of the presenters is, I think, about 68. Our oldest presenter is 83. And his name is David Hamilton, and he's been in the business. He started in radio in 1958, and he is just on top of his game. You listen to that program, and you just hear every link bang on, smack, smack, smack. He's the most professional person I think I've ever worked with. We've got presenters who were on the pirate ships, you know about pirate radio in the UK in the 60s. We've got a couple of presenters living in Spain. They do their programs into the system. So the
And did we lose him? I think we lost Howard. Oh no. Okay. All right. We got to wrap anyway. We're gonna we'll get
and the music is the kind of music they want.
Ah, there he is. Is he there? Not really. All right, put it back on me. All right, well, we got to go. I will get a stream. I'll get a link for you that you can click on to hear Boom Radio. And I'm sorry, Howard, we were within a minute of having to go anyway, so I was going to have to wrap it up. Quentin Howard has been our guest, and we'll have a link to him as well. Hey, thanks a lot to Suncast for producing our show today. Thanks to Andrew Zarian, the founder of the GFQ Network. And I'm Kirk Harnack. We'll be back next week with another great edition of This Week in Radio Tech. Thanks. Bye-bye, everyone.